1D motion practice, problem number 3. So while standing at the edge of a roof of a 7.3 meter tall building, so let's start drawing a diagram. So the very top of this is 7.3 meters, so I'm going to let that be the height there, and down here at ground level I'm going to let that be 0 meters. A student tosses a ball upward at a velocity of 11.2 meters per second. So here's the ball, and the initial velocity upward is 11.2 meters per second. Well, already I'm going to see that gravity is going to be involved with this. So gravity will be down, so the acceleration is g, which is, let's use 10 meters per second squared. And since I've got both directions going, I need to establish what direction is positive, so I'm going to let up be plus. So that means this will be negative 10. All right, so now he fails to catch the ball on its way down, so it strikes the ground shortly after the toss, neglecting air resistance. Good. A, how high above the roof does the ball rise? In other words, for this first part of the journey, starting here, it's going to go up until it stops and then starts back down. So up here, the velocity is going to be 0 meters per second. And we want to know how high. So we have an initial velocity, a final velocity, and acceleration, and we're asked to find how high. So I'm going to let delta y be that. So I'm using y instead of x in all my equations because the motion is vertical. So what is delta y? And the most direct way that I can think of to do this is to use the equation that the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the change in position. So the final velocity squared equals the, oh sorry, I already wrote that. So the final velocity squared minus the initial velocity squared minus subtracting the initial velocity squared divided by 2a equals how high. And when we work all of that, it turns out that how high is 6.3 meters. So that's the answer to part A. It goes 6.3 meters above where it was released, above the roof. Don't overthink these and try to, figure out, well, the student isn't, adds height and everything else. Well, unless they tell you how tall the student is, we're just going to assume that it leaves at the top of the roof. B, how much time lapses before the ball strikes the ground? Okay, so to do this, so the ball strikes the ground, so the final height will be 0 meters. The initial height is 7.3 meters. The ball is going to start with an initial velocity upward, so that makes it positive 11.2 meters per second. And it's undergoing acceleration due to gravity, which is negative 10 meters per second squared. And the question is, how long does it take, how much time until it hits the bottom? So we can treat this completely separately from the part A. We can pretend part A never happened because this question might have just started with this portion and never asked part A. The equation to use is final position equals the initial position plus the initial velocity times time plus 1/2 the acceleration times time squared. Because we're looking for t, right? We're looking for t. So final position is 0. Initial position is 7.3 meters. The initial velocity is 11.2 times t. And 1/2 a is 1/2 of negative 10, so that's minus 5t squared. So we have a quadratic equation. And so to solve this, we could use the quadratic formula, or we could graph it on our graphing calculator and find out where the positive t answer is. Either case, we end up with an answer of 2.8 seconds. So it's going to take 2.8 seconds for the ball to go up and stop at its maximum height and come back down and then hit the ground. So that's the answer to part B. And part C asks, well, what's the ball's velocity when it does hit the ground? Oh, okay. So let's see, we're going to work that out. Let me try over here. So part C, what is the final velocity after being 2.8 seconds in free fall? So final velocity is equal to the initial velocity plus the acceleration times time. So in this case, the final velocity is equal to 11.2 meters per second plus negative 10 meters per second squared times 2.8 seconds. And notice seconds times meters per second squared, this result will be negative 28 meters per second, added to 11.2 meters per second, yields an answer of negative 16.8 meters per second, and the negative connotes that it is downward, which makes sense. And so that's how we do the third problem.